By the end of this lesson, you should be able to determine whether two events are independent, to apply the multiplication rule for the event A and B, to apply the conditional probability formula. The probability of an event, given that another event has already occurred, is called conditional probability. The conditional probability that event B occurs, given the fact that event A has already occurred, can be represented by the probability of B given A has occurred. Notice you'll also see the conditional probability formula, which we will use later in this section. Compound events. Probability problems containing the word "and" usually involve compound events. A compound event consists of two or more simple events. Now, these events can be either independent events or dependent events. For independent events, the outcome of the first event has nothing to do with the outcome of the second event. In other words, the outcome of the first does not affect the outcome of the second. Dependent events, on the other hand, the outcome of the second is going to depend on what happened first. So in other words, your second event is going to depend on what remains after the first event has happened. When you're solving probability problems involving compound events, you want to pay close attention to certain keywords, because these keywords can help you determine whether an event is an independent event or a dependent event. Words like "with replacement," when you hear that, that is an example of an independent event. Let's say I had a bag of marbles that contained 2 reds, 2 blues, and 1 yellow. And I want to find the probability that I will select a red marble first and then a blue. So when I reach in the first time for the first event and select a marble, whatever marble I take out, if I replace that marble and put it back in there, when I go in for my second event to take out a marble, the outcome of the first event does not affect the outcome of the second event because we replace the marbles. A dependent event, on the other hand, the outcome of the second event is going to depend on what you did in the first event or what happened in the first event. So let's say with those marbles, the first time I took out a red. And so in taking out a red, if I do not replace it, and by the way, for dependent events, that's a clue when you hear "without replacement," meaning you did not put it back. So let's say I took out a red the first time. So when I go in the second time, not only am I less 1 marble, and I have, instead of 5 marbles in that bag, there is now 4 marbles in that bag. And the fact that I took out a red, originally I had 2 reds. I no longer have 2 reds. I have 1 red left. So that is a case where we call dependent events, because again, it was a case where the outcome of the second event is going to determine what you did in the first event, what you took out. Okay, so just keep in mind those keywords with replacement and without replacement. Using the multiplication rule of probability for independent events. Find the probability of flipping heads with one coin and rolling a 5 with a dice. Well, the first question you want to ask yourself is, are events A and B independent? Now, event A represents flipping a coin. Event B represents rolling a die. So are these two events independent? Well, the answer is yes, because flipping a coin and getting heads or tail has nothing to do with rolling a dice. So therefore, these are what we call independent events. When you have independent events, all you have to do is find the event or the probability of each one and then multiply them together. Again, the probability of two independent events is found by multiplying the probability of the first event by the probability of the second event. So let's start with the first event, the probability of flipping a coin and landing on heads. Well, you know that a coin has only two sides. One of the sides is head, so that's going to be 1 over 2, which is a 1/2 probability of that occurring. Event 2, or event B, is rolling a dice and landing on a 5. Well, how many sides have a 5? Well, since there's only one side out of the 6 sides that have a 5, that probability is 1/6. So now all we need to do is multiply the two fractions. On top, 1 times 1 is 1. For the denominators, 2 times 6 equals 12. So therefore, the probability of flipping a heads and rolling a 5 with the dice is 1/12, or you can write it as a decimal or as a percent. A box contains 5 triangles, 6 circles, and 4 squares. If a shape is removed, replaced, and the second figure is picked, what is the probability that a triangle and then a circle will be picked? Well, these are two compound events. Notice you see here the and. So with the first event, it is the probability of selecting a triangle. That's event A. Event B is selecting a circle. Now, before we can calculate the probability of these events, let's find out how many shapes we have in all. So if we add the 5 plus 6 plus 4, we have a total of 15 shapes. Now let's find the probability of the first event, event A, of selecting a triangle. Since there are 5 triangles and we have a total of 15 shapes, the probability of selecting a triangle is 5 out of 15. And now let's do the event B, the probability of selecting a circle. Now keep in mind that since the shape that I took out the first one was replaced, I put it back in, that means the box still contains 15 shapes. So the outcome of this second event B is not going to be affected by the outcome of the first event. So how many circles are there? We have 6 circles in the box out of the 15. So the probability of selecting a circle then would be 6 over 15. So when you want to find the probability of compound events that are independent, all you need to do is to multiply the two fractions. So multiplying the top, 5 times 6 is going to give me 30. Multiplying the bottom, 15 times 15 is going to give me 225. Now you don't have to reduce the fraction in this case if you're going to write it as a decimal or as a percent, because all you're going to do is just do top divided by the bottom. But if you're going to leave your answer on any of the homework or tests, if you're going to leave it in fraction form, then yes, you do need to make sure that your fraction is reduced. But again, you can write the answer in decimal or percent form. So the probability that a triangle and then a circle will be picked is 2/15 or 0.13 or 13%. And there you have it. And now let's work with the multiplication rule of probability with dependent events. Two events, A and B, are dependent if the occurrence of one affects the occurrence of the other. The probability that B will occur, given that A has already occurred, is called the conditional probability of B given A is written as the probability of B given A. And there you have, if A and B are dependent events, then the probability that both A and B will occur is the probability of A and B equals the probability of A times the probability of B given that A has already occurred. Let's do some examples so this will make sense. A pet store has 7 puppies, which include 4 huskies, 2 terriers, and 1 retriever. Suppose 2 puppies are selected without replacement. Find the probability that both selected are huskies. So the first thing we want to do is identify whether this is an independent event or a dependent event. Well, we have a keyword here, our keyword without replacement, meaning you took the puppy out, but you didn't put it back in there. So recall that when that happens, that is an example of a dependent event, because when you go back in the second time, you're not going to have the same number of puppies in the basket because you didn't put it back. So you have 1 less puppy. So you must account for that when you take out your second event. So this is an example of what we call a dependent events. And with dependent events, you're going to find the probability of the first event, because the first event is not going to be affected because nothing has occurred yet. However, when you go in the second time, you're going to find the probability of event B given the fact that A has already occurred, meaning you have to account for what you took out with A. Okay, so event A is selecting a husky the first time, and then event B is going in and selecting another husky. So our sample space, then recall we have 4 huskies, 2 terriers, and 1 retriever. So since we have 4 huskies, when we go in the first time, our probability of selecting a husky would be 4 out of the 7 puppies that are there. Okay, so 4/7. And now remember, originally we had 7 puppies in the baskets. We took 1 out, we did not put him back in there, so now there are only 6 puppies left. So with our second event, event B, we have to account for what we did in event A, which means that both the top and the bottom has to be 1 less. So now let's find the probability of getting another husky. So we started with 4 huskies. We got to go 1 less now. So the probability would be 3. And on the bottom, we're also going to have 1 less. So the probability of getting a husky again would be 3/6. And now all we have to do is simply multiply these numbers together. If you're going to write your answer as a fraction, make sure that you simplify your fraction. If you're going to write it as a decimal or percent, you don't need to simplify. You can just simply do top divided by the bottom. And there you have it, the probability of both puppies selected being huskies are 2/7. And these are what we call dependent events. There are 7 dimes and 9 pennies in a wallet. Suppose 2 coins are to be selected at random without replacing the first one. Find the probability of selecting a penny and then a dime. So the first thing we want to do is to determine whether these 2 events, events A and event B, whether they are independent or dependent. Well, there was a key word in the sentence, and that key word was without replacing the first one, which means we took a coin out the first event. However, we did not put it back, so that means when we go in for event B, we're going to have 1 less coin in there, so that means our outcome is going to be affected. That number is going to be different because it's 1 less. So this is an example of what we call dependent events. So let's let A be event A selecting a penny, event B selecting a dime. We want to start, because they're dependent events, start by finding the probability of A, and then we want to find the probability of B given the fact that A has already occurred. So let's first start out by finding the probability of A, which is of selecting a penny. Well, first of all, how many coins do we have in the wallet? Well, 7 plus 9, that's going to be 16. So we have 16 coins in the wallet. And how many of those coins are pennies? That's correct, 9 of them. So the probability of event A is going to be 9/16 because 9 out of 16 of the coins are pennies. And now we want to find the probability of event B given the fact that A has occurred. Now, since we did not put that coin back that we took out, we now have 15 coins in the wallet. But this time I go in, I want to select a dime. So how many of those coins are dimes? Well, there are 7 coins that are dimes, but I have a total of only 15 coins left, so then my probability of selecting a dime, given the fact that I took a coin out, is going to be 7/15. Now, all we need to do at this point is simply multiply these 2 events, and we have the probability of these compound events. So let's go ahead and multiply these 2 fractions. We have 9/16 times 7/15. We can simply multiply them across. If you're going to write it as a fraction, you need to make sure that your fraction is simplified. You can also write it as a decimal or as a percent, and in that case you don't need to reduce your fraction, just do top divided by the bottom. In either case, the probability of selecting a penny and then a dime is 21/80, or 0.26, or 26%. And there you have it. There are 5 tiles with the letters A, B, C, D, and E in a bag. You choose a towel without looking and put it aside, and then choose another towel. Find the probability that you will choose a consonant followed by a vowel. So here we have two compound events. Notice here that you have first selecting a consonant and then followed by selecting a vowel. So recall, consonants are anything that are not your vowels. Your vowels are A, E, I, O, U, and sometimes Y, and your consonants are everything other than that. Okay? So event A is going to be the first towel selecting a consonant. The event B is going to be selecting a vowel. Now, in determining whether these events are dependent or independent, if you look at the keyword, it says that you took one out without looking and you put it aside, and then you got another one. So that means that after that first event, you didn't put it back. So these are dependent events. So when you go in that second time, you're going to have one less. It's going to be affected by the fact you took out something from the first time. So with dependent events, recall the formula for that is you have to multiply the two events. First, find the probability of A, then find the probability of B, given the fact that you account for what you took out on A. So let's start by finding the probability of event A. And event A, of how many are consonants? There are 3 out of the 5 towels are consonants, and those consonants are the B, C, and the D. So that would be 3 out of the 5. Now when I go in the second time to get a vowel, remember we no longer have 5 towels in the bag. We have 4 towels in the bag. But this time when I go in, I'm looking for vowels. So how many in the bag were vowels? Well, we only had 2 vowels, and the 2 vowels were the A and the E. So then the probability then would be 2, and we only have 4 left, so that would be 2/4, which is the same as 1/2. So the probability of B, given that A has already occurred, is 1/2. Now to go ahead and find the probability of these two compound events, recall we're going to have to multiply the two fractions, which is called the multiplication rule. So let's go ahead and multiply the two together. 3/5 times 1/2. Multiplying the top, 3 times 1 is 3. Multiplying the bottom, 5 times 2 is 10. So therefore, the probability that you will choose a consonant followed by a vowel is 3/10. Recall, you could also write it as a decimal or as a percent. Next, we want to talk about contingency tables. So in this section, we're going to understand and use contingency tables to solve conditional probability problems. A contingency table is a table chart that records data in which different possibility situations result in different possible outcomes. The table and the conditional probability formula can be used to determine conditional probability. So here we're given a contingency table that shows the number of students who play baseball. We're asked to find the probability that a student plays baseball given that the student is a senior. So we're going to use the conditional probability formula to help us solve this. If we read the probability statement, it says, find the probability that a student plays baseball, that's event B, given that event A, that the student is a senior. So we're going to let A be a senior and B plays baseball. So to find this conditional probability, you have to start by your numerator finding the probability of both A and B. And since A and B is being a senior and playing baseball, we want to go over to our contingency table and look for playing baseball and the fact that you are senior. And so that number is 34. So on top of our fraction of our formula, we're going to have 34. On the bottom, we want the probability of A, and event A is that you're a senior. If we look over in our contingency table, the second row represents our seniors. 34 of them play baseball, 306 of them do not. If we add those two numbers, we have a total of 340 seniors. So the probability of event B, given that A has already occurred, is 34 over 340. And of course, if we're going to leave it in fraction form, we must reduce our fractions. 34 of the seniors play baseball out of 340 seniors. So when we reduce that fraction, that's going to leave us with 1/10. And there you have it. The probability that a student plays baseball given that the student is a senior. At Clean Paws Pet Grooming Salon, pet owners bring their cats or dogs in to get bathed only or bathe and groom. The contingency table below shows how many animals the salon serviced this week. So to find this, we're going to use the conditional probability formula, which is, if you want to find the probability of B given A, first find the probability of A and B over the probability of A. So let's classify our events and find out what's event A and what's event B. If we read the statement, it says find the probability that an animal was bathed and groomed. So whenever you have given in there, the first event that you come to, that's event B. So that an animal was bathed and groomed is event B, given that event A has already occurred, and A is that the animal is a cat. So let A be a cat and let B be bathed and groomed. So now we want to find the probability of A and B, and that's the fact that it is a cat and it has been bathed and groomed. So we're going to go over to bathe and groom, and where it is cat, and what we have here is 12. Next, on the bottom, we want event A, and event A is a cat, so we want to get the total for cat, and row 2 here are the cats, so 3 plus 12. So 3 of the cats was just bathed only, 12 bathed and groomed, but we still have a total of 15 cats. So probability of B given A is going to be, recall 12 is going to be on top, and then we're going to have our 15 on the bottom, because there are 12 cats who were bathed and groomed, and there were a total of 15 cats in all. So our probability is 12 over 15. And of course, if you're going to leave it as a fraction, you need to make sure you reduce your fraction. If you're going to write it as a decimal or percent, you don't need to reduce it. Just do top divided by the bottom and go ahead and convert it. But to reduce our fraction would reduce to 4/5, and there you have it.